This is example 11.4 part B. Some of these examples have multiple problems within them. So this is the second part of the example found in module 11. And it states that a gas mixture contains 456 torr of oxygen, 112 torr of carbon dioxide, and 501 torr of nitrogen. What is the mole fraction of each component in the mixture? So what they want to know is what part of the total mixture does this 456 torr or pressure of oxygen contribute? So, and what part of the total pressure does the carbon dioxide contribute, and what part of the entire mixture does the nitrogen? And so we have a couple of equations that we might need to use, right? And both of these are kind of restating Dalton's law. Dalton's law really is the sum of all the partial pressures found of the individual gases of a mixture of gas. When you have more than one gas in a container, the sum of those partial pressures equals the total pressure of the entire gas mixture. And another way we can state that is that there's a relationship between the partial pressure of a gas, the mole fraction of that gas, and the total pressure. Again, the pressure of a gas doesn't depend on the identity or what that gas is, but how much is present. And so when we talk about the mole fraction, it's giving kind of it's kind of giving the percentage of how much of that gas is makes up that total pressure. And if we know how much is there and we multiply that times the total pressure, that will also give us the partial pressure of that gas. And I didn't write down all the variables here, but you can see that what we're given is the partial pressure of oxygen, carbon dioxide, and nitrogen. And so the total pressure of this mixture of gas can be easily found by just simply adding up the partial pressures for each of these gas. So we have 456 torr is the partial pressure for oxygen, plus 112 torr for carbon dioxide, and 501 torr of nitrogen, for a total of 1069 torr. And again, when we're adding, we don't necessarily look at how many significant figures are in each of these numbers, because in this case there would only be 2, but what we're looking at is what is the least precise number involved. And all of these numbers go to the ones digit, and so we keep our answer extending out to the ones digit. So this is the correct significant figure here. Now that we have the total pressure, if we go back to this equation, right, because what we're looking for is this mole fraction. We have the partial pressure of each gas. It's given right here, 456 for oxygen, 112 torr for carbon dioxide, and 501 torr for nitrogen. We've just now used this equation to find the total pressure. So now we know this one. So now all we have to do is find the mole fraction, and this will be relatively easy to do because it becomes, we just plug in those two values and solve for mole fraction. And so if we look down here, right, so if we take a look at oxygen, remember the partial pressure for oxygen is 456 torr, so we're going to replace that in the equation here. We're looking for the mole fraction, what percentage or what part of the total does oxygen contribute or is. And we know that the total pressure, we just solved that, is the 1069 torr. If we divide both sides by 1069, that leaves us with the partial mole fraction on the right, and 456 torr divided by 1069 torr. The torrs cancel. Remember, this is a dimensionless or unitless measurement, because essentially if we were to multiply the final answer by 100, it gives us what percent of the pressure is contributed by oxygen. So here again, now we are since we are dividing, we have to use the least number of significant figures. In both this case, there are 3 significant figures, so we are going out to thousands position, but we have to look to the number to the right, and if that number is a 5 and above, we must round this number up. So our final answer, our mole fraction for oxygen, is 0.427. And now we're just going to repeat that same process for carbon dioxide and nitrogen. Okay, so here's carbon dioxide. Its partial pressure was 112 torr of carbon dioxide. We want to know what the mole fraction is, so we're going to multiply that by 1069 torr, divide both sides by 1069 torr. And again, we need 3 significant figures. The number in the 4th significant figure position is greater than 5, so this 4 we round up to a 5. The mole fraction for carbon dioxide is 0.105. Remember, because there are 2 significant figures on either side, that 0 is significant. There are a lot of rules to remember when we're doing this. And lastly, what is the mole fraction for nitrogen? The same process. We know our partial pressure that was given in the problem, 501 torr of nitrogen, and we're going to set that equal to the mole fraction times 1069 torr, which is our total pressure. Divide both sides by 1069, and which will result in 0.469 is the mole fraction for nitrogen. And interestingly, if you all of those should add up to approximately 1. All right.